So values of trigonometric functions at any angle. Here is a problem. Evaluate cosec of minus 1410 degree. Again, we divide 1410 by 360. So 363s are 1080 and 364s are 1440. So 1440 is more than 1410. So the quotient is 3. And here we have 1080. So remainder is 330 degree. But this angle minus 1410 degree, minus sign means we are forming the angle clockwise. We are forming the angle clockwise. And so 3 is the quotient. It means 3 complete rotations will be there. Three complete rotations. So one rotation, this is second rotation, and then there is the third rotation. After that, we can make an angle of 330 degree in the clockwise direction. So 330 degree will be up to this. So here will be the final stage of the revolving line. So this angle is 330 degree. Actually, we write cosec of minus 1410 degree equal to cosec of minus 360 degree multiplied by 3 in the bracket plus 330 degree. That means divisor into quotient plus remainder. So this is cosec of minus 360 degree multiplied by 3 and minus 330 degree, distributing the minus sign over the inner bracket. Now we know 360 degree means complete rotation, whether it is one rotation, two rotation, three rotation, that brings the final line to the initial line, that is 0 level. So that much can be ignored. Only the remainder part is left. So this angle is, which we need, this is the angle in the clockwise direction, that means minus 330 degree. Now this final line, if reached by the clockwise direction, requires 330 degree rotation. But if we reach the final line by the anti-clockwise rotation, we reach the same line by 30 degree. So that means we can have this cosec ratio of minus 330 degree as same as cosec of 30 degree. And cosec of 30 degree means 1 of sine 30 degree. And sine 30 is half. So this is reciprocal of half. So this is 2. I hope this part is understood. I hope this part is understood. Anyone? Nobody is saying yes?
Yes.
Yes. So I can proceed to the new topic now. That is, I will be going to discuss the circular system for the measurement of angle. So just a minute, I open the new page. I am closing this. Circular system, but it is sharing the first screen of this system. This is about the definition of radian. What is a radian? Just as we measure the length in meters and we measure the length in feet also. For example, if some person who is tall, in meters, he may have the height 1.8 meter, but in feet, perhaps approximately, I am saying 6 feet. So if unit of measurement is changed, the number of units for measuring a certain quantity also changes. See, meter is a bigger unit. 1 meter is slightly more than 3 feet. So in meters, the height of a person is given by a smaller number, like say 1.8 meter. But in feet, feet is a smaller unit, the number of units will be more for that person's height, say 6 feet. So same way, when we measure angle in degrees, degree is a small unit, as you have seen on the protector. On the protector, you have seen that there one straight angle is divided into 180 equal parts, and each equal part is known as a degree. So 180 parts, making 180 parts of a straight angle means we are getting a very small unit, which is degree. But radian is relatively much bigger in size. What is radian? So I am going to explain. This is an entirely new system, well, a modern system of measurement of angle, which is used in higher mathematics, means +1 onwards, and in theoretical physics also. So here is the definition of radian I am going to give. A radian is the angle subtended at the center of a circle by an arc equal to radius in length. See the diagram. See the diagram which is made here. Circle has the center here. Radius is r. Arc length is also taken equal to r. Arc length is taken means arc length. That means if you travel on the arc, on the curve path, then the distance traveled is equal to r. That is the meaning of the arc length equal to r. The distance from this point to this point, direct distance or the straight distance, we are not talking about. We are talking about the distance traveled on the arc, that is equal to radius. Then the angle subtended at the center by this arc is taken to be 1 radian. So as visible in the figure, this is a much bigger unit of the angle. Is the definition understood? Yes.
Sir, yes.
Okay. Everyone. Okay, then I am closing the screen. Next, we will go to the estimation of how much 1 radian is equal to. We will try to know what is the value of 1 radian if we talk the value in degrees. what is its value approximately, estimate we want to find. I am sharing the screen. So in the diagram, O is the center of the circle with radius r. And this orange part, orange colored arc is, that is arc AB. I can show the arc AB like this. Arc AB is of length r. That's why the angle AOB, where O is the center of the circle, this is 1 radian. So as I told earlier, we are traveling a distance equal to r on the arc. But if we travel straight distance AC equal to r. Suppose I say that AC is also equal to r. AC is the straight distance which is equal to r, while AB is the arc distance. While AB is the arc distance which is equal to r. So it is clear that if we go straight, we will go farther than the point B. So C point is farther than B as measured from A. But if you travel distance R on the arc, because arc is a longer way, you will be able to travel up to say point B. But if you travel from A to C straight, equal to distance r, then C point will be farther than the point B. Is this clear? Is this point of mine clear?
Sir, yes.
Everyone? So, what happens? What is angle AOC equal to then? Who can tell angle AOC how much it will be? Jasmeet? Yes, man. Anmol? Anyone? Okay, nobody is knowing. See, OC is also a radius. This is equal to r. OA is the radius. So OA is also equal to r. And we have constructed AC equal to r. Therefore, triangle AOC is an equilateral triangle. Now tell what is the angle AOC equal to?
Sir, 60 degree.
Yes, now it is clear, it is 60 degree. So we are able to form the estimate about the angle AOB. Angle AOB as shown in the diagram is slightly less than we write like this. Less than, and this type of curve is standing for slightly. So slightly less than angle AOC. But angle AOB by definition, it is 1 radian. So 1 radian is slightly less than 60 degree. So is this point clear?
Sir, yes.
So next, we may I close the screen now?
Yes,
Sir,
sir.
yes.
Okay. So next we are going to do an important relation between the arc length and the angle. I am sharing the screen. What I have done in this picture, I have made a circle. Suppose its center is O and this point is A. I have taken AB arc, AB arc. And this is the angle formed at the centers. Then we talk of AC arc. As you see in the figure, I have made AC arc twice of AB arc. AB arc is subtending angle theta at the center. And AC arc, if you can see in the figure, how much angle AC arc is subtending at the center? Is it 2 theta? Is it clear
Yes, sir.
to all? And similarly, if we take this point D, what I have done, I have taken AD arc equal to 3 times AB arc. In comparison to AB arc, AD arc is 3 times. Naturally, here another angle theta will be there. So that the AD arc is subtending the angle 3 theta at the center, right?
Sir, yes.
So can we say if we denote arc length by L and angle if we denote by theta, then can we say L is proportional to theta? This is the proportionality. Okay, as much we increase the arc length, that much times the angle is increasing. This is a direct proportionality.
Sir, yes.
All are able to understand?
Sir, yes.
Only one Amraz is speaking, I think. Or Anaj, what about you?
Sir, yes. Understanding.
Okay, Anmol.
Yes, sir.
Okay, then I hope it is clear to all. And one thing we previously discussed in some class also, that ratio of directly proportional quantity is constant. L upon theta is arc length divided by angle is constant. Is it okay?
Sir, yes.
Now we are interested in this constant actually depends upon the system of measurement of angles. Now we have studied the radian system. In radian system, yeah, in circular system of measurement for angle, when arc length is taken equal to radius, coming to the definition of radian, remember arc length is taken equal to the radius, then angle theta is equal to 1. 1 in radian system, when we have written above circular system means it is understood that it is 1 radian. If arc length is equal to radius, we define the angle to be 1. Remembering the definition today I told? Yes, Jasmine?
Sir, yes.
Sir, yes.
Okay. So what we do, we put the values of L equal to R here and theta equal to 1, but constant remains constant. That won't change. So constant is equal, sorry, what I have done is R divided by 1 I have to do. L is equal to R, theta is equal to 1. So this is equal to constant. That means the value of the constant is equal to R. Hence, we have got the important relation between the arc length and the angle. I am writing here, here, relation between arc length and angle in radians. The angle is being measured in radians. Then what happens? Constant is equal to r. So if we use this relation, L by theta is equal to value of the constant is equal to r, or we have the result L is equal to r theta. This is a very important result to be remembered. So what does this result means? Arc length is equal to radius multiplied by the angle, but angle is not in degrees. Angle is not in any other system than the modern system of measurement of angle. That is, angle theta is being measured in radians. Okay. Is this point clear?
Sir, yes.
So can I close this screen now? Or you are trying to understand or taking snapshot or anything? So I am closing the screen now. And one more thing we will be able to do today. I think at least two things if I can do today, that will be good. This is your last class in the timetable. If I take 1 or 2 minutes more, maybe, then doesn't matter. So I am sharing I try to do this second last for today. This is a simple thing. We are going to find relation between degrees and radians. If we take arc length equal to pi r, for the radius r, pi r as shown in the diagram represents the length of the semicircle. Length of semicircle, you know what is the length of semicircle? Pi into r, because full circumference is 2 pi r. I hope this is clear.
Sir, yes.
What is the angle made at the center? Again, using the formula we have just derived, L is equal to r theta. We put the value of L equal to pi r. So r theta, r cancels. Theta is equal to pi. As I have written here in the diagram, pi. It is the angle made at the center, pi. Pi has approximate value, you know, 22 by 7, which is approximately 3.14, slightly more than 3. Okay. But
Sir, yes.
you also know that if we measure the angle in degrees, then this angle is 180 degree. So you can say that pi radians is same as, means 3.14 radians approximately. If we say approximately, this is either 22 by 7 radians or 3.14 radians, means slightly more than 3 radians is equal to 180 degree. Is this clear? But if we write pi, then we understand we are writing the exact value of pi, which is given by an infinite decimal, non-terminating and non-repeating decimal, because it is an irrational number. So pi radians is equal to 180 degree. This is clear.
Sir, yes.
So I am closing this screen so that I can discuss one thing more, the importance of this result. So I have sharing this screen. We already know that a radian is smaller than 60 degree. A radian is slightly less than 60 degree. Here also it is clear because we know that pi radians is equal to 180 degree and pi means 3.14. So 3.14 radians are approximately equal to 180 degree. Why 180 degree is equal to slightly more than 3 radians? Had 1 radian been exactly equal to 60 degree, then there would have been exactly 3 radians in the 180 degree, but it is not so. Already we have understood that 1 radian is slightly less than 60 degree. So 1 radian is slightly less than 60 degree. Therefore, 3 radians are slightly less than 60 degree multiplied by 3, or you can say 3 radians are slightly less than 180 degree. So in the picture, this is clear, right?
Sir, yes.
And but from this very relation, we can find 1 radian, how much exactly, not exactly, but approximately 1 radian's value we can find. The last part is a calculation part. Because pi radian is 180 degree, therefore 1 radian is equal to 180 degree divided by pi, which can be taken approximately equal to 180 degree divided by 22 by 7, because we have used the approximate value of pi. So this is how much 180 degree multiplied by 7 over 22. 2 cancels out. Here 90 degree. So this is 630 degree divided by 11. And this is 11 fives are 55. Then 8 becomes 80. 11 sevens are 77. Then 3 remainder. 3 becomes 30. So 11 twos are 22. So 8 remainder and 8 will again become 80. So you can say approximately this much degrees. Okay.
Sir, yes.
So this is about the circular system of measurement of angle. And the last very simple thing left, as we write degree by this symbol, we write radian by writing small c in the superscript form, like we write degree here. C stands for circular system. And sometimes we write it as only number also. Because when we are talking about the angle, it is understood that this is not just a number, there is some unit also. But when we are not writing any unit, it is understood to be a radian. This is convention. This is convention. Just like in mathematics, plus is written like this, minus is written like this between two numbers. But multiply is written this way also. Sometimes A into B like this also. Sometimes no symbol is taken. When no symbol is taken, then it is understood to be a product. Okay. So similarly, if C is written here, it stands for radian. But if nothing is written here and we are talking about the angle, then angle cannot be just a number. It is some number times some unit. So 180 degree is equal to only pi, means pi radians. It is understood. Okay. I hope
Sir, yes.
so. This is all about the today's lesson. I can close the class now. Fine. Just a minute. Let me take a snap of your attendance. today more students have come. Okay, now I am any doubt in the today's lesson?
No, sir.
Okay,
No, sir.
okay, then I am closing the class. Okay.